In this session, we're going to talk about system thinking and system control. So making sure that the system is in control. And again, if we want to improve the overall performance of the company, we first must have the system stable. And then once we get stable, then we can get the process or the system capable. So I'm going to talk about what is process control and then how that applies to the system perspective. So we want to be able to understand when our system is operating normal and stable. And then once we get to that point, we can move to getting the system capable if it's not capable at that point. So when we look at process control, what is a process? Again, it's inputs that we do some action or activity and we convert those inputs into some desired outputs. Now we can look at it from a system perspective, and a system is just the same thing where we have inputs, but we have multiple process steps to create the output. So again, a system is a combination of different processes where the output of one process is the input for the next, and multiple processes make up an organization, and all organizations can be described as a system. What are the types of variations? So when we look at a system, we can break variation down into two components. First is common cause. So common cause is the variation that's inherent in the system. In order to reduce this, we need to change the system. The other type of variation is special cause, which is an event that happens sporadically or unpredictably and causes the system to go out of control or become unstable. So we need to classify what type of variation we have in the system, because the actions to reduce common cause are changing the system. The actions to address special cause is looking at what are the assignable causes or the reason that it happened and putting in the preventive measures to prevent that from happening in the future. So we want to focus on first reducing special causes of variation. So these are the things that are causing disruptions in the flow. So anytime we have disruptions in the flow, then we need to understand what are the special causes that are creating that. So those are the things we talked about in the previous video, such as equipment breakdowns, minor stoppages, speed loss. All those things are special causes of variation. We need to figure out from the root cause what is creating them and put in the permanent countermeasures to eliminate them. Simple statistical techniques can detect special causes of variation. So there's some simple things we can do from a process control perspective at different processes in the system to understand when they're operating normal and when they're not. And if they're not operating normal, taking immediate corrective action to address them. And especially if we have a constraint within the organization, we want to focus our efforts there first. Then if we take the proper action, we understand what actions should be taken, who's responsible for taking those actions. We can quickly react to those. And again, the faster we find the problem, the less disruptions it's going to create downstream. So the faster we can react to those issues, the amount of chaos that that creates by causing more problems downstream is eliminated. Once we get stable, then we can start focusing on common cause variation. So for example, if we don't have enough capacity to meet our customer demand, we need to figure out how to open up capacity. And again, the common cause is management's responsibility. So Deming said that 94% of all problems that are caused by the system need management involvement. So the managers are the ones that need to take action to reduce common cause variation. So a system is said to be in statistical control when all sources of variation come from common causes. One function of process control is to understand when common cause is happening and when special cause is happening and taking the appropriate actions to address what type of variation you're seeing. So one mistake I see a lot of companies do is they take management action when it should be local action. So they're classifying special causes as common causes and vice versa. So we need to understand what type of variation we have before we can take the appropriate action. What is stable and what is capable? So if we can measure the system performance, and it doesn't matter what measures we use, here I use in sales order delivery performance, we take our current system, we measure how we're performing in terms of delivery performance, it might look something like this. Hopefully yours is much higher than that, but I can take this data, I can take the average, and I can take 3 standard deviations to calculate our upper and lower control limits. So if you do nothing different, the outcome is highly predictable, saying somewhere between 20 and 58% will be your due date performance if you continue to operate the way you're operating today. Of course, this system is stable because it's predictable, but it doesn't mean it's capable. Stable means predictable. If there's special causes of variation, that creates instability, and simple process control measures can identify when that's happening. But what we want to do is say, okay, what is our customer expectations? Of course, they want high delivery performance and reliability. So what we need to do is we need to reduce the variability. And again, to reduce that variability, we need to take management action. And then we need to shift that average up to get the process both stable and capable. Then once we're at this point, then we can start to focus on creating more business value by focusing on the right areas to improve overall performance of the company.